I want to go ahead and welcome everyone to this month's AGU-AGI Heads and Chairs webinar. My name is Leila Gonzalez. I will be sitting in for Christopher Keene today. And joining us is Pranoti Asher, who's the Assistant Director of Grants and Education Programs at AGU, and Eva Kostu, who's the Program Manager for the AGU Bridge Program. And so with that, I'm going to go ahead and turn it over to Pranoti to introduce our speakers.
Great. Thank you so much, Leila. I appreciate that. Welcome, everybody. So we're so glad you're able to join us today for our webinar this month. We have two fantastic speakers and a very popular topic. So I can't wait to hear what they have to say. Maria Sharova is the Thriving Earth Exchange Community Science Fellow Program Manager. She works with their growing network of fellows as they manage community science projects around the world. She is particularly interested in facilitating their science engagement through, project design, management, and evaluation. She worked with the Smithsonian Environmental Research Center prior to being at AGU. She's also worked at the Ecological Society of America, and she holds a bachelor's in anthropology from the University of Maryland and a Master of Science in Fisheries, Wildlife, and Conservation Biology from North Carolina State University. Joining Maria is Natasha Udu-gama, who serves as the director of the Thriving Earth Exchange. She supports a team that is sort of increasingly interested in helping those who want to do community science all around the world. She has been at AGU since 2014 and contributes her over 10 years of disaster risk reduction, climate change adaptation, and community engagement and partnership experience. Her Ph.D. is in environment and geography, where she specialized in multi-sector partnerships for effective and sustainable community-owned early warning systems. And she received her Ph.D. from Macquarie University in Sydney, Australia. With that, Natasha and Maria, please take it away.
Thank you so much, Pranoti, and thank you to AGI and to all of you for requesting this particular webinar. So welcome. Today's webinar is on equitably addressing community priorities, geoscientists and communities, co-creating tools and solutions. So another title slide, but I just want to introduce myself. I'm Natasha. My pronouns are she, her, and for those of you who may have difficulty seeing, I have short black hair. I've got a blurred background and I'm wearing a gray blouse. I want to also acknowledge that I'm speaking to you from Hyattsville, Maryland, on land taken away from the Anacostan, Piscataway, and the Nacotchtank peoples. And I'm in a country, the United States, that enslaved people. So Thriving Earth Exchange is the arm of AGU that fosters partnerships between communities of place, advocacy, interests, you name it, we work with them, and scientists like yourselves to advance local priorities through an approach known as community science. Our mission at Thriving Earth Exchange is to strengthen and enhance collaboration among communities, scientists, and partner organizations so that all communities can build healthy, resilient, thriving, just, and ecologically responsible futures. Our vision is a leader in contributing to global well-being by supporting communities' awareness and application of science. And we promote equity by ensuring that all communities benefit from the opportunity to participate in, contribute to, and guide the use of scientific knowledge. So for almost 100 years, Thriving Earth Exchange's Earth and Space Science, AGU's Earth and Space Scientists have been very good at the first part of AGU's mission, which is promoting discovery in Earth and space science, primarily through their research and publications, both within AGU's domain and beyond it. It was very much following this top-down model, or a loading dock model of science. So essentially, the researcher typically does the science that is then ingested by the public, found, and then integrated into decisions or into community guidance. In the decade prior to our centennial in 2019, AGU realized that our Earth and space scientists weren't as good at the second part of the AGU's mission at the time, which is bringing benefit to humanity. Naturally, many would have thought that there was an impact of a loading dock model by doing their science and presenting it to the public wasn't that beneficial in and of itself. However, after much discussion, our senior leaders and Thriving Earth Exchange leaders at the time realized that benefit to humanity wasn't happening under AGU auspices, and they wanted to change that. So by 2012, the concept of Thriving Earth Exchange had been born. And by 2013, we were operationally putting into practice benefit to humanity by advocating for co-production, also known as community science. So that is communities and scientists working together to advance a community priority. And because we're AGU, those priorities typically related to climate change, natural hazards, natural resources, environmental health, pollution, resilience, and sustainability, so as to develop feasible and impactful tools and solutions. So in co-production, there's more of a bi-directional communication between the researcher and the decision maker, creating more dialogue and more cross-pollination of ideas, concepts, knowledges, and practices. Ultimately, we believe this process of co-production makes for both science and the tools and solutions much richer and more holistic because they've had the input from multiple sources and ways of knowing. So community science provides an additional approach to science, one that extends beyond basic research and towards solutions, one that is up to the challenges we face now in our modern times, one that reaches across disciplines, and one that takes on issues of equity and justice that have been ignored or repressed for way too long. Community science is a way of doing science that begins and ends with those community priorities, as I mentioned before. And scientists and communities, science and other ways of knowing are all partners in all the steps in the process of science. And I want to suggest that we can help foster this kind of approach, and that we want to go even further and say that AGU, through our strategic plan, is already doing many of these things. And through Thriving Earth Exchange, we've been able to do this for the last 10 years. So this slide pretty much shows community science situated between many different terms, between community-based participatory research and use-inspired science, to be more specific. But it is part of that larger spectrum that we at AGU call solution science, and it is often referred to in numerous ways, including the rest of the terms shown on this slide. So as I mentioned before, this is the definition of a community science. So the process by which scientists and communities do science together to advance one or more community priorities. It encourages communities, particularly those that are historically marginalized and oppressed, to guide, participate in, learn from, and benefit from the sciences. So it's really important to note this last part, because longstanding, and also that the fact that community science has been worked into and been worked on prior to AGU in the public health areas, the natural hazards, ecological management practices, agricultural extension, tribal and community and historically Black colleges as well. So let me tell you a little bit about some of the 3 key principles of community science that Thriving Earth Exchange is pretty much founded upon. Without these principles, we might simply be engaging or involving communities, but by adhering to these particular principles, we at Thriving Earth Exchange are ensuring that community science remains as much as possible co-produced, iterative, and a constant dialogue between peers coming from seemingly disparate walks of life. So first of all, community science always begins with community priorities. And some might say there are issues or challenges or problems, but we like to say priorities. And at the core of beginning with community priorities is having the ability to listen, not just listening to respond, but to authentically and actively listen for better understanding and context. It is never about scientists telling a community what to do, but it's always about asking a community what they would like to do, what they aspire towards, and then finding ways by which earth and space science can contribute to. And by actively listening, we build sound relationships with authenticity and respect. Furthermore, beginning with community priorities also means a recognition that we ought to engage broadly, understand that communities exist within communities, and that the safety of all is involved. And it's a very powerful model of partnership. How can we basically help that community accomplish your goal? So to put it another way, instead of talking about the co-benefits of climate migration, we might offer climate mitigation as a co-benefit of a community priority. And that word, as I mentioned, the word priority is really important because it's all about positively framing a community capacity. A mayor once said to our vice president of community science, and I remember this so distinctly because she said to him, "I am tired of rich cities having priorities and poor cities having needs." So this is why we particularly formulate this in this manner. The second principle is ending with community impact. And one of our catchphrases within Thriving Earth Exchange is a paper is not an outcome. We want to end with something that is different in the community, in people's lives, because of the project that they're doing with our Earth and space scientists. We always want to ask what is different or what will be different in the community after this work has been completed. So think and start small. Oftentimes, I think in both AGI and AGU, we do something called SMART goals. And we're often and that means what is specific, measurable, attainable, relevant, and timely. In our case, our community science fellows might ask community leaders, what can be achieved that can basically help set up a community for that next step in a larger priority within an 18-month period? What might be accomplished, say, in 6 months, if that's all that your team has time for? And then producing meaningful outputs is all about what makes the most sense for the community, given their time, resources, priority, and skills and expertise of the scientists and fellows on the team. As you'll learn shortly from my colleague Maria, some outputs could be additional flood data, a new GIS map outlining areas of risk, or simply a community meeting discussing impacts of hydraulic fracturing upon a water system. Ultimately, our projects will aim to support the community with questions they are asking that are pertinent to a specific priority or issue. And last but certainly not least, we believe science is a human right. All communities deserve the opportunity to ask and investigate their scientific questions. Community science projects plan the project, develop a communications plan, and budget all together. Data is always co-managed. Data will never be shared until and unless the community is willing and able to do so. If they don't want to share their data, it's also their prerogative. If a scientist wants to publish a paper from this work, they should aim to do it with their community leads and, at a minimum, obtain the permission from them to publish. And ensuring human rights also means communicating openly, frequently, and effectively. Too often, science is available to the privileged, and we can and should make science available to all, so every community can contribute to, benefit from, participate in, and help guide that scientific research to tackle the issues they care about most. Scientific societies like AGU and AGI are in a position to ensure that science can be used. And in the case of this pictured example here on the slide, the community lead, Amy, wanted to get rid of I-10, which decimated her neighborhood, and it was built because it was built when the neighborhood itself was built like hundreds of years ago. We then connected her with scientists, and they collected noise and health data, creating a curriculum, and launched balloons with elementary school kids. Her work has been mentioned as part of Biden's infrastructure plan, with funds allocated to undoing this kind of harm. And so beyond that, I want to just, basically pull all this together and tell you a little bit about whose community science benefits. It benefits communities in that it really helps those communities become more resilient and sustainable. And it enhances communities' abilities to participate in, contribute to, help guide, and benefit from the sciences. And then overall, it chips away at pressing global challenges. We're not saying that it actually solves all the global challenges, but it definitely helps us move the needle towards each of these communities actually being able to address those challenges, those global challenges that are affecting them locally. And then it benefits science because it helps to generate new research questions and approaches. Isn't it awesome if the public as a whole can start to affect the research agenda, not just the scientists who ask those questions? And it basically helps to increase the public support for sciences. If the public themselves are able to get involved, then they will be more supportive of what science and technology and technical expertise can do for their communities. And then finally, it really helps scientists hone those skills and prepare for diverse careers. So diversity, equity, inclusion, and justice are very central to community science, and community science is very supportive of these key areas because it enlarges our conception of what counts as science and who can be part of science. It's an ally for communities that are tackling injustice. We work with communities of all types, as I mentioned, including neighborhood groups, by offering science and as a tool to ask and investigate their questions. And then it's also a way for science to learn about equity from community organizations that have been more experienced with equitable ways of working, such as developing community agreements, which is something that we've learned from community organizations that we've now brought into the practice of community science at Thriving Earth Exchange. So Thriving Earth Exchange, as I mentioned, has been around for 10 years this year. And we've done over 250 projects, involved 532 community leads and multiple scientists, community science fellows since 2019, and worked in about 135 unique cities and regions, 39 states, and 10 countries. So with that, I will turn it over to my colleague Maria to tell you a little bit more about how Thriving Earth Exchange has been impactful in communities. Thank you.
Thank you, Natasha, and thank you everyone for being here. My name is Maria Sharova, and I am the Community Science Fellow Program Manager at Thriving Earth Exchange. And all of those words will make a lot more sense in just a couple of minutes, so bear with me. First, a little bit about how we actually do all of those wonderful things that Natasha just shared about, all of those principles. How do we actually put those into action? So we offer a flexible kind of framework for doing these projects. It's illustrated by this diagram here: scope, match, solve, and share. And I'll go through each of those on my next slide. But in general, we provide this framework to communities, to project teams. We match community scientist pairs, typically individual scientists rather than whole institutions. And then each project has a dedicated project manager, which we call a community science fellow, that helps build the bridge between the community and the scientist. Projects are free to communities, so everybody involved on these projects is typically a volunteer. And projects have an 18-month duration with the opportunity to end earlier. So with that, I would love to talk a little bit more about our approach, the scope, match, solve, share. So this is a framework, and it's meant to be just that. It's meant to provide enough structure and support so that project team members never have to wonder what's next or how do we do this. But it's meant to be helpful in adapting our approach as it makes sense to project needs and goals. So scope is all about developing this top bit up here at the very top. It's about taking that initial priority and making a project plan of action. That's when you take that question and put it into actionable steps. What are we actually going to do, and how are we going to do it? Match is about taking that project scope and then finding the technical expertise to carry out that scope. We call the role on the team a community scientist, but we mean that very loosely. It can be any technical expert that can help carry out the scope of that project. And then share is this inner green circle, and it can happen anytime throughout the process, but it's all about sharing the milestones and results and outcomes of a project. And for some projects, share is very much part of the scope and the actual doing of the project. And then solve is all about completing the project itself. So that's the most unique piece to every project. And I'll talk about a couple of examples in just a minute to illustrate kind of how these things might work in action. So I mentioned that every Thriving Earth Exchange project team has 3 roles. The first is the community lead, and that's the person on the team who represents the broader community. They bring the insights, the connections, they represent and speak on behalf of the community. The community scientist is that technical role that brings the scientific knowledge and insights and connections and engages as a representative of the scientific community. They're the ones who make sure that the science is relevant and responsive and meaningful for the community's priorities. And then there's the community science fellow, and those are the folks that I help recruit and orient and support throughout their time on the projects. And they're essentially project managers. They're the ones who guide the team through the process, ensure that communication and coordination is happening. They're the ones who help the community lead kind of figure out what that scope is, make sure that it's an appropriately leveled scope. And they're the ones who help find that technical expert, that scientist role to help join the team. So I mention all of these terms because I'm about to use them in these examples of communities in action. And as Natasha pointed out, and I would like to reemphasize that community science is with communities, not necessarily like that more top-down approach. So here's 3 points that I would love to bring to the forefront and consider. There's power in including all voices, but also consider what voices are at the table. In the case of community science, building something that is most useful for the community is important to the success of a project and to the impact of that project. And that second point about defining a community science question, that might take more time and energy and conversation than a traditional way of doing science, a traditional like research study that is more top down. But building consensus towards that community priority is a really important step in emphasizing community voice and in ensuring community impact. And the third point I have here is really around humility and patience. Communities have lived experience and may not have the same priorities that a scientist has. However, science can help communities reach those priorities in ways that also tackle a scientist. So I have about 2.5 examples next of projects that are either complete or in search of a scientist right now. And I'd love to go through those next. So the first project that I'd love to talk about is the one in Santa Rosa County, Florida. This one very recently wrapped up. And its title is Mapping Natural and Developed Resources to Encourage Responsible Growth. So the community's challenges and priorities related to promoting more responsible development connected to infrastructure and flood risks and affordable I'm sorry, I skipped way ahead of the summary of this project. Okay. Santa Rosa County is located on the Gulf Coast of Florida in Santa Rosa County, Florida, and they have experienced very rapid growth. They've doubled in population since the year 2000, and the growth was really stressing out the county's natural resources, which is the thing that brought people to that area in the first place. So leads from a grassroots community action group wanted technical support to better understand how policy and code development could more adequately protect the natural resources and promote more responsible development. So this community applied to work with Thriving Earth Exchange, and we matched them with a fellow and scientific support to help carry out kind of the scope of this project. So what did scope actually look like? The community's challenges and priorities were, like I said, about responsible development, infrastructure, flood risks, affordable housing, traffic. They wanted to really take a holistic look at all of these things. And in this first phase, which again we call scope, they had a series of conversations with their fellow to co-design a project that would be the most meaningful in advancing their priorities. Again, they wanted to protect the community's strengths, namely the natural features and qualities that had drawn so many to the community by promoting more responsible development through the county code. But they also wanted to better understand what risks and assets to inform engagement with county policymakers and developers who they felt like were dismissing their concerns. So in scope, they identified the kinds of technical support that would help them to better understand those risks. So based on these conversations, the fellow recruited and interviewed scientists and technical support, and the team ultimately consisted of a geologist, a stormwater engineer, and a community resilience ArcGIS professional, Amy, Chris, and Ryan, all listed here. Once the team was assembled, they got to work mapping the elements that influence quality of life in Santa Rosa County to inform their engagement of county leadership and developers. So what they did was they developed an ArcGIS map, which includes wetlands and parks and green spaces and waterways and all of the kind of man-made features as well. Landfills, contaminated sites, leaking underground fuel tanks, retention ponds, municipal recapture system, roads, all of these kinds of layers. And this community map became the go-to reference and the most impactful tool for all efforts to build sustainable communities throughout Santa Rosa County, including applications for grants, advocacy for existing policy enforcement, and revision and updating of the county land development code and zoning statutes. And so the share portion of this project, the part where the team kind of communicated about what it is that they were doing, they passed an updated land development code that did not really address the community leads' concerns. And within a year, many of the risks that their map had demonstrated, especially related to inland flooding, had come true. And so the community leads shared that they felt like prophets and that the map helped them develop a credible voice on sustainable development in the county. Local newspapers began to regularly contact the community leads about new development, and they present the map each time a new development is proposed. And so now, a year later, the county is revisiting the Land Development Code to address some of those risks that their map highlights. And this project in Santa Rosa County and this awesome team really highlights how Thriving Earth projects can be one step towards a much longer and bigger path that uses science as a way to inform future decision making. And so I'd also love to drop the project description in the chat, if I can find it very easily, for you all to check it out further. Okay. And so I'd love to talk about a second example, and that's one in Glastonbury, Connecticut. And I might move a little bit quickly to this because I want to save lots of time for questions. So this project was all about addressing uranium contamination in Glastonbury, Connecticut. And so what happened was, so uranium is naturally occurring and can be found in certain types of rock. And in Glastonbury, Connecticut, there were high uranium levels in private drinking water wells that are kind of scattered throughout the city, so the region, the area. They knew about certain clusters of uranium, of high uranium concentration in groundwater wells, but they didn't know about it in other areas. And so homeowners started testing for this, and they were finding lots of high levels of uranium where there was previously no reported uranium. So kind of like a what's going on here situation. So Thriving Earth Exchange worked with community leads to better understand how uranium is affecting the town water supply. So again, in the project scope, the ideas were to gain a stronger understanding of the impacts of naturally occurring uranium, understanding the factors. Why is it here? Why is it happening? Why is it different in certain areas of this town? And then understand how other US communities have been affected by naturally occurring uranium concentration, and developing a public communication campaign, because knowledge is power and people deserve to know what is in their drinking water or in their well water. And so from the Thriving Earth's network of volunteer community scientists, the team brought on Dr. Hari Kandel, who is a geosciences Ph.D. and assistant professor at Lake Superior State University, who is an expert in hydrology, and Dr. Rachel Coit, who at the time was a graduate student and is now a postdoctoral scholar at Ohio State University. And the project actually kicked off in April 2019. And so as part of this project, the team of scientists were looking at water patterns and geology, so overlaying those kinds of map layers, and determined that the town's bedrock was linked to the naturally occurring uranium concentration in the private wells. So there was basically a major geological structure that is the fault under the town, and the structure is different throughout the town and is responsible for the higher concentrations in certain areas and lower concentrations in others. The team also found that uranium concentrations could be affected by rainfall. They could be seasonal, and it is dependent on the height of the water table. So in short, Glastonbury has a highly variable geology, and interactions between the deposits and the rainfall were really challenging to predict where uranium actually is higher or lower. And so now what? What did the team do? Once the team had finished reviewing the data, they drafted an in-depth report that covered the cause of the uranium contamination, and they finalized and published reports in 2021 that were posted on Glastonbury's official website. And to go along with that, they also produced a 2-page plain terms summary so that community members and town leadership could quickly and easily understand the results of what they were seeing and what their next steps should be. So that's kind of that example there, and I will drop the link to this project in the chat as well. Please bear with me. Okay. And then third and final example, and it's, please forgive me, it's a very light, if you want to get involved, please consider this project kind of a thing. So the purpose of this project in the city of La Crosse, Wisconsin, is to develop heat strategies for mitigating heat. By identifying specific areas where green spaces can be installed and potential policy options, the city will be able to work with community partners to implement practices that will benefit current residents, including vulnerable populations like the unhoused, and increase the city's resilience against future extreme heat events. So this project is currently in match and currently seeking that technical expertise, and they would love to learn about options for addressing heat islands. They would really love to develop recommendations for mitigating heat islands and help develop a plan for a demonstration project. So in general, the project team is looking for people who can brainstorm options and provide those policy options for mitigating heat islands. And if you or someone you know might be interested in this or any of our other 30-some projects that are currently seeking technical expertise, please consider checking those out here, and I'll drop another link in the chat. These are just some of the wonderful ways that you can get involved in community science projects, and I'll talk a little bit more about that here. Like I said, projects are interested in getting that technical expertise. Technical expertise is wide-reaching. We get a lot of PhD students, postdocs, early career, mid-career, late career, all across the spectrum. Try your hand at something new. These opportunities are meant to be worked into a regular job schedule, and project teams are thrilled to have the expertise on a project. And then finally, you can join as a community science fellow. Like I mentioned at the top, I'm the program manager for those fellows, which means I'm the person on our team who recruits and orients and supports these fellows throughout the duration of a project. So if you're interested in learning more about that, I'm happy to chat about that. And with that, I will say thank you very much and would love to take some questions.
Great. Thank you. Thank you so much to both of you, Natasha and Maria. So as we get questions in the chat, let me take my privilege of asking you the first question. As you noted that you've worked with, postdocs, grad students, you work with folks who are early and later in their careers. For those who are early in their careers, how do you know how folks can use the work that they're doing with you towards sort of tenure or promotion or to get their next job? Do you have stories, or do you have things that you do to help these folks? If you could answer that question, that would be terrific.
I can talk a little bit on the fellows side before I'm sure Natasha has other things to add. On the community science fellows side, I hear countless stories of how folks, especially in the early career sciences space, are using their experience on Thriving Earth Exchange to leverage that for future jobs in the academic spaces. So that broader impacts thing, it's checked. They are continuing to support a community, working on community priorities, working to support a community science project, and they get that kind of expertise and support by working with us in a really well-resourced way. We have a team of 6 that is always here for fellows and communities and scientists. So they're never alone in their process working through this.
And then in addition to what Maria says, when it comes to community scientists, we've oftentimes had requests for letters of support to get tenure or to become, a dean of a school. So that has been beneficial for some of our scientists to, proceed in their career as well.
I should also plug, I should also plug Community Science Exchange. This is both a journal and unjournal within AGU, and it's meant for people to be able to publish and get academic credit for working on a community science project. But it's also an unjournal in that the journal requirements are kind of a little bit less than a traditional journal might be. So if you're interested in that, I just dropped the link in the chat.
Great. Thank you so much. Leela, if you want to monitor the questions that are coming in through the chat, that would be great.
Absolutely. Actually, we have one here from Scott who's asking about how do you reach community members? So how do community members find the Thriving Earth Exchange, and how do you advertise to them?
That is the quintessential question Pranoti you were asking earlier. So that's a great question, Scott. Thank you. So initially, as you all know, we are AGU, we're a scientific society. So we didn't traditionally have connections to communities of place and other types of communities that we work with. So initially it was, word of mouth. It was, we had a consultant who basically gave some cold calls. We had personal connections. But by 2015, we decided and we developed what we call community serving organizational partnerships. So these are partnerships that we have with organizations like the International City and County Managers Association, the National League of Cities, the ICLEI Local Governments for Sustainability, other umbrella networks of community organizations and communities that basically boast, hundreds, if not thousands, of different types of communities of place and of type. And so that has been really, really effective in us being able to encourage those networks in encouraging their members to apply to be communities. And then I think in the last few years, we've had a lot of word of mouth from the communities themselves who have, in, say, the Ohio River Valley, there are a lot of hydraulic fracturing affected communities that we reached out to in 2017, and we've seen sort of a knock-on effect of more communities, unfortunately or fortunately, who have come to us saying that they do want to explore more projects in their respective areas. So I think, and then there are some communities that have come back to do projects to build on some initial projects that they've done with us as well.
Great, thanks for that.
I can ask another question. So how are these projects funded, for some of the assets that you have to create, or, extra work that has to, how is that funded?
Yeah, that's a great question. So like I mentioned, projects are typically everybody on the project team is a volunteer. We do offer $1,000 in project like reimbursement funding. It's not a lot of money. It's just there for project like materials, travel, and like mileage reimbursement, sample running. It's not meant to be the long-term like 5-year stable thing. The Thriving Earth Exchange project is really just the first step into a larger thing. So that's what we're there to support.
I've got a follow-on question here from the chat. So Caroline's asking, how do you track project outcomes? I imagine quite a few projects start as a text project and expand with new funding. And so she's curious to know, how do you track that at all, that whole life cycle? And as you're saying that, you might start small and then go into something bigger. Can you talk about your tracking of that and how that goes?
I guess one of the basic ways that we track our community science fellows essentially will provide monthly updates, monthly status updates to our team. And that's sort of how we sort of track, like, are they getting media sort of attention? Are there specific outcomes that are coming out during the life of the project? And then, over time, I think this kind of builds on sort of Maria's last response. Is that, a lot of these projects, we don't necessarily track what's happened like 6 months or a year after the project completes, though we are working on being able to do that. However, we will sort of, make sure that we do sort of an exit interview with all of the participants in a project. And if we have missed anything, we oftentimes find more by the end of the project, but that's definitely something that we want to be able to track better over time. And oftentimes too, projects will tell us, oh, we received this funding because we partnered with these scientists. And oftentimes it's a great way for communities to essentially provide some really good background and foundational materials for proposals, because they've worked with scientists with AGU and beyond. They're oftentimes able to get further funding to get to the next step of their sort of ultimate goal.
Thanks for that. What about working with other organizations? So there's a question here from Tyler about, have you ever partnered with the NASA developed national program to help address community concerns? And if so, how has that happened?
Yes, actually, we've worked with NASA Develop on a number of projects. I think at least 4, maybe even 5. I can drop a couple links in the chat in just a second. But typically, they work with us as the technical experts on a project. So they assemble teams and help the community leads and the fellow address whatever the priority might be. So typically, they're in that like technical expert scientist kind of a role. And that role doesn't have to just be one person. It can be several people, as it usually is with NASA Develop.
We've got quite a few more questions rolling in here. So Robert's asking about, have you worked with in rural communities, for example, limiting influence of agricultural runoff or infiltration on surface water or groundwater quality? Do you have projects that are similar to that?
Oh, yes, that's a great question. And we want to do more with rural communities, I should say. But we have worked with really, really rural communities, like the mayor that I mentioned. She was the mayor of a very small town in Georgia, maybe about 300 people max. And then another small community in Kansas we worked with was just, I think, just about 200. And then most recently, a small town in Alaska that's mostly indigenous, also about like 500 or so. But we do, look for opportunities to connect with more rural communities as well.
And can you also talk to how you work with communities in other countries? Because that's another question coming in about who proposes those projects and how do you get connected with those contacts?
That's a great question. So initially, we just tried some projects. We were given a mandate by AGU to try community science in the United States first, make sure that it worked before trying to export something that wasn't fully defined. But I, as someone who had worked outside of the country for a long time and as part of the team at the time, I was very excited about the opportunity that AGU had with members in 147 plus countries. So we were able to try a few projects, and that basically meant, having some personal connections. It meant, connections through other AGU staff. But now in the last few years, especially during the pandemic, we worked directly with organizations based in other countries regionally, or I think there was like 8 different organizations we worked with during the pandemic to basically impart our community science approach and allow them an opportunity to learn it through our online learning management system and adapt it and start projects as they wanted to. So that enabled a group in Australia to start a couple of projects in Australia. There's a group in Ghana that started a couple of projects there, and another group in Senegal that's worked on sort of agricultural runoff issues in Senegal. But if you're interested in, if anyone on this call is interested in, starting an initiative in another country, we have a colleague who's just started who will be really focused on this going forward.
And Adriana, I've gone ahead and enabled your mic, so I know your hand's up. So if you want to ask your question.
Hi, everybody. Thank you so much for the great presentation and the information that you gave us. It's awesome. I just wanted to ask a question about partnerships, or basically, I'm trying to learn and I'm going to be kind of trained in how to work with communities and doing community-based science and what you're talking about, basically. And I'm actually working on a proposal for an organization. So I was wondering, you kind of mentioned that you provide like a small amount of funds for community scientists or community members to work on projects, or I guess geologists, if I understood correctly, like volunteers. But do you also kind of work together with funded projects, or like, is there a way for us, for example, to include funds to work with you? So I found out about your program, I guess, a while ago. So I was wondering, since I understood that you don't have like too much in terms of funds for people to work on projects, so would it be possible to kind of partner? So if I get the grant, then we would talk basically, right, and partner, so that I don't know how to do it yet. You are super experts on how to do that, obviously. And can we partner so we can work together and get resources for the projects? And also to pay community members to participate in the projects, like say collect water samples and pay them for the time. So like a real partnership, I guess. So that's a long question, but it's like, is there a way to partner? Have you done that or not? And if I have more questions, I can just, if I can email you, that would be awesome. Thanks so much.
Definitely. Yes. Thank you so much for your question. And definitely, you can always reach out to us, email the team or me. I can also drop in my email. A great question. We've definitely had some projects where they have maybe obtained some funding and then required, Thriving Earth Exchange expertise in connecting with some scientists for a portion of the project. Sometimes they have the funding before, sometimes after, but as long as it's sort of with the community, we're totally on board for, the community getting additional funding to be able to provide more resources to the community leads. We do realize that, a lot of community leads are not necessarily working for government or municipalities and are not doing that work for their communities on that's not their full-time job. So we do recognize that a lot of these community leaders are doing multiple things and are stretched in multiple ways. And so we are looking for opportunities, and we will have more opportunities in the future to be able to provide some stipends to communities. I should also mention, in response to that previous question, that we are at the moment sort of looking for opportunities to include more English-speaking communities in the Western Hemisphere, so in Latin America, Central America, the Caribbean, and we've started working with more communities as part of Thriving Earth Exchange, who are, like, say, in Jamaica or in Mexico. And by mid-year, we will have a specific project coordinator who will be working on Spanish language projects. So if you're coming from any part of, Spanish-speaking Americas, we would, encourage you to get in touch with us in the coming year, because we will be wanting to include more communities, Spanish-speaking communities, and be able to support them better moving forward.
Awesome, thank you. Can I follow up quickly? Just 1 second. Can you hear me? Yeah, so I'm a professor actually at in the US, but I am fluent in Spanish, let's say. So yeah, that sounds really, really amazing. Thank you so much. I will probably just send you an email. Thanks again.
We got one question here in the chat too, asking about, do you have any projects working along the coastal regions, such as South Louisiana, in indigenous communities, working with them on coastal erosion or rising sea levels? And if so, can you talk to those?
Yes. Yeah, go ahead, Maria.
I was just going to say that there's a number of projects located in Louisiana. If you go to that projects link that Natasha sent a couple of messages ago, you can sort by location and by community type. Off the top of my head, I don't think that there's any indigenous community representation from Louisiana, but there absolutely is from Corpus Christi, Texas, which is, not the same place, but along that coast. So yeah, if you know of a community that would like our support or would like to start a Thriving Earth Exchange Community Science Project, please share their information with us or share our website with them. We're always welcoming new communities and launching projects. So anything else to add, Natasha?
No, that's pretty much it. We did have a couple of projects that we started with indigenous communities in coastal Louisiana, but unfortunately, there were complications. So always looking to, connect with more indigenous communities everywhere in the country. But if you have any particular connections and, email addresses and people that you can connect us with, we're always looking for additional connections with more underserved and marginalized communities.
Lila, I can ask another question. Of all the folks that you work with, whether they're community scientists or your project managers, what is sort of the demographic of the folks that you're working with? Are they mostly early in their careers, or are they mostly, well-seasoned scientists who are retired, and want to engage back with the community? So can you speak to that? Thanks.
You just hit the two big demographics, Pranoti, I think, which is pretty typical for volunteers across the US. It's that kind of like early career folks or people who are later in their careers, but we welcome anybody on the fellows side from any education background. The only kind of I always say that the best kind of prerequisite for being a good community science fellow is humility. That's really the biggest thing. Career experience is not a great indicator of fellow success, at least on that end. On the scientist end, I'm sure that helps a little bit more. But on the community science fellow end, where you're being a project manager and being there and being the point person for a community, early career, even like post-undergrad, is just fine.
And are there specific topics that you are looking for in terms of projects? Do you have areas that you have special expertise in from your past projects, or areas that you'd like to explore more? Can you talk to that?
So we never set the agenda for any of these projects. It's always, as I mentioned earlier, and as Maria mentioned, about the community priorities. And because we're AGU and we have such a wide variety of experts from the core of the earth to the surface of the sun and everything in between, plus we're connected to organizations like AGI and ESA and AAAS and all the acronyms, we are able to basically connect scientists of all types to any type of community that is looking for so the sky's the limit. If you have a question, if you're a community, you have a question, if we don't have that core expertise, we will do our diligence, our best. Our fellows are amazing, and they will look for the right types of scientists to work on those projects.
Thank you. I'm just Adriana has a question here real quick, so go ahead and unmute Adriana, and then after that, Tyler's got a question.
Thank you so much. I may have missed a couple of minutes at the beginning, so if you talked about it, it's okay. You don't need to repeat it, but if you haven't, I was wondering, when you work with the communities, I was wondering about the background of people who work with communities, and you mentioned being humbled and, of course, knowing how to talk to people and to relate and to not doing the old science helicopter, basically same thing as before, even with maybe the good intentions. So do you work with and get advice, or some of you have the sociology or psychology, I guess, background, or how do you work with that? Because I work with people and colleagues, for example, and so some of them say, well, we don't need a sociologist because I know how to talk to people and stuff like that. And I'm like, I'm not a social scientist expert, and to try to understand different things and do things right, it seems like the right thing to do is to have a sociologist, or I think sociology is the best. But I wanted to get your opinion on that. Thank you so much. Silence.
Okay.
Big question.
I was hoping that maybe Maria might talk to this. So one of the things that Maria is really good at doing, and the team, is essentially looking for community science fellows, those volunteer project managers who have a specific skill set. So they might be scientists themselves. They might be really able to do the technical and scientific work anyway, and oftentimes they are scientists in their own right. But we, the way we also look for scientists, the way we also look at fellows is, do they have the ability, do they have those soft skills, the way that can they connect with people on a human level? So that's what we're kind of looking for. And when it comes to community science fellows and in community scientists as well, we can easily find the expertise in our database within like a 5-minute search, but then really trying to understand, do these people have the ability to connect on a human level, is definitely another thing. So I remember a few years ago that, when Thriving Earth Exchange was still sort of an adolescent, well, not even adolescent, a toddler program. And we were asked to sort of talk about the initiative to, I think, within a group of other organizations. And one of the organizations present was actually the American Sociological Society. And I think subsequently they started a very similar kind of connection of sociologists to communities. However, I would say that, we're always inviting in, I'm a geographer by background and a disaster manager. So I think we're always very open at AGU, and I think in other societies, for different folks from different backgrounds. And, we do our due diligence that if they need a sociologist, we will do our best to find the sociologist, the geographer, the anthropologist, as it might be. Maria, is anything else?
Yeah, the only thing I would add is that, especially, well, I control this on the fellow side, but when fellows are seeking technical expertise to help support projects, if they come across folks who don't seem super into the community science idea, that's fine. We encourage them to move on. So like, we're not going to convince anybody that community science is a good and worthwhile thing. And I don't want to put a scientist in front of a community that might end up causing harm. So I guess I would just want to point that out, is that we seek humility and empathy from fellows, but we also ask fellows to seek that from the scientist end as well.
Tyler's got a question. So Tyler, I'm going to go ahead and enable your mic. So you should be able to unmute. Go ahead and ask your question.
Cool, awesome, thank you. I'll try to make it quick. I see the meeting is kind of coming to an end. But first, I just want to thank you for doing this. This is awesome. This is the first time I really got to engage with anybody at AGU. I'm actually just learning about this program. I learned through NASA Develop. I'm sure you probably realized when I asked that question that I am a Develop alumni. I'm actually finishing my second project, but I'm really obsessed with how involved, like, Develop cares about the community. I know they do, which is why I love it. But it just seems like AGU is just so embedded with the community concerns, and I just love that aspect of it. So I've been trying to figure out how I can get involved, and I'm curious to know, since you're familiar with Develop and the research participants, which I am, where at AGU do you think somebody as a research participant, where are those skills most applicable at AGU? You know what I mean? Like, what position, like if I would apply to AGU for my next early career position, being an undergrad in environmental science, where do you think those developed skills are most applicable? Thank you.
I think if it's post-undergrad, Community Science Fellowship is a great place to start. There's a number of other wonderful AGU initiatives, but yeah, if you're interested in Thriving Earth Exchange, please check out our opportunities. There's no real experience hard limit on it. I ask for fellows to be out of undergrad, but that's more out of undergraduates are more transient than folks who are post-undergrad, and that's just a factor of we want there to be consistent support on projects. But that's neither here nor there. If you're interested in working with Thriving Earth Exchange, please don't hesitate to apply. Next cohort launch is going to be, deadline is May 10th, and the cohort launch is June. So
May
soonish.
10th, and that's for the fellowship?
Yep.
Awesome.
And then scientist is ongoing basis. So
cool. If you had any kind of link or source for that fellowship, I would love that. That would really help me out. Yeah, school got me really busy, as you can imagine, so that would really help me out. Thank you so much for answering the question.
Yeah, Leela, let's just take this one last question and then we can wrap up.
Okay, so our last question for the day is, how do you have community members evaluate scientists for projects?
I think that's a great question. So essentially, as Maria was talking about earlier, the community science fellows essentially will look for the scientist and the technical expert, and they do a thorough sort of search. They do interviews, and then they present to the community maybe a few options of who might be best suited. And we recommend no more than 5 scientists just to keep it really tight. But basically, the fellow will present some options. They'll have an opportunity to connect with those potential candidates, have a call. And if after that call, the community leaders decide, we don't want to work with these people, they can say that, and we will do that process again. But there have also been certain times, and I think even recently, I think on the fellows orientation last week, we had a community lead who was talking about the fact that she was involved in the selection of the scientists. And this has happened once before that as well, as far as I can remember. So we encourage that if that is something that the community leads want to do, but it's certainly not something that they have to do, but they always have the choice. We don't tell them who they should be working with.
Great. Thank you so much. This was terrific. So Leela, if you want to just go to the next slide, we need to wrap up. Thank you very much, Natasha and Maria, for your time. We really appreciate this. Yes, the presentation as well as the recording will be available. If you have additional questions, please reach out to the presenters. You're welcome to even reach out to me. We have lots of other opportunities for those of you who are interested in engaging at AGU, including the Heads and Chairs community. And last but not least, we have another webinar next month. And that is about, if you could just go to the last slide, thank you very much. It's about a new career tool for the geoscience community called GROW. So hope to see you then. It's on April 14th. Have a great weekend, and thank you very much for coming to this webinar today.